focus on the standard procedure for the conduct of the cohort study and on the characteristics and other features and of the cohort study designs, and as well as we are going to discuss the source of bias in cohort studies, and as well as we will discuss the measures of association between the exposure to a certain factor and the outcome. And we start with talking about the standard procedure for conduct of cohort study. We have the inclusion and exclusion criteria are to be stated clearly, showing the important features and characteristics that are going to be considered in the design. And thus, we need to carry some sort of estimation of the required sample size using the standard formula or appropriate software. So there are special software for estimation of the sample size for the cohort studies. And then we collect the information about the exposure, because we need to subdivide the cohort members into exposed and non-exposed, smokers and non-smokers, contraceptive users and non-users, and so on and so forth. This is very important among the cohort members, and we can use different data collection methods such as questionnaire, laboratory investigations, laboratory techniques, and so on. And then we have to follow up of both exposed and non-exposed at specific intervals to record any newly diagnosed cases. So after we have subdivided the cohort members into exposed and non-exposed, smoker and non-smokers, and then, for example, we are going to follow them for a period of time so that we can easily diagnose the new cases that will arise among both groups. So we have to follow both the exposed and non-exposed for a certain period. Then we compare the incidence rate among both the exposed and the non-exposed. So long we have the newly diagnosed cases and we have the population at risk, then we can calculate straightforward the incidence rate among the exposed group and the non-exposed group. And the study based in the person time experience of individual in whom the outcome is certain. And the study base should be the same for both the exposed and non-exposed in cohort studies. Thus, the denominator for calculation of incidence rates must be the same number of people for the same period of observation, so that we can estimate accurately the incidence rate, and calculation of the person years at risk is the means of achieving equivalence of study base in cohort studies. The source of bias in cohort study, we have the selection bias, which is which is an important source of bias, because we are selecting a special group, those who are exposed and those who are non-exposed. So the selection bias is there, and we have to care for this. Then we have the surveillance bias. There may be variations in detection of disease between exposed and non-exposed. In other words, that if those who are diagnosing the cases or following the cases, if they know that the member is exposed to the certain factor, then they can go into details. They can detect the disease in a depth manner, rather than compared to those who are not exposed. If the investigating doctor or the researcher knows beforehand that this individual is non-exposed. So here we can, here there will be surveillance bias. Information bias may result from non-response of some of this subjects or the participants, or interview may introduce bias information in the information collected from the subjects. Also, we have misclassification. Sometimes there will be some of the community members may be misclassified. For example, if an individual who is a smoker for 30 years and for the last 6 months he become non-smoker, then he will be classified as a non-smoker. And this is misclassification. And also, if an individual is a non-smoker for a long period and then he became a smoker for 3 months, for example, the last 3 months, then we are going to consider him or her as a smoker. And this is an example of misclassification. Also, we have the attrition, that there will be losses over period. There are so many of the, maybe there are many of the cohort members will leave the place, will leave the town, will migrate, will die due to other reasons, and then will be some sort of attrition for the cohort members continuously. And bias in the analysis also could be another source of bias. And the measures of association in cohort study incidence rate per unit time among exposed, incidence rate per unit time among non-exposed, cumulative incidence rate among exposed, and cumulative incidence rate among non-exposed. These are the measures of association. And then we can talk about the relative risk and the confidence interval for the relative risk, attributable risk, the odds ratio, and also we need statistical tests such as chi-square testing and Fisher-Exact test and Kaplan-Miller method, and proportional hazard models are to be used for testing the statistical significance between the exposed and non-exposed. The relative risk is the ratio that measures the strength of association between suspected cause and effect or the outcome. And the relative risk is a measure that of the relevance, relative magnitude of the cumulative incidence in exposed and the incidence among the non-exposed. We have the attributable risk, also called attributable proportion for a causal association, and the proportion of caseload that can be attributed to a particular exposure. It is a causal attributable difference, attributable risk, divided by the incidence rate in the group. It is the proportion by which the incidence rate would be reduced if the exposure was eliminated, or and usually it is expressed as a percentage. We have here example of 2x2 table for carcinoma of the bladder and smoking, and we can see the smoking status in the columns, and as well as those who develop the bladder and those who did not develop the CA bladder, and as well as the total. And then we can apply the calculation. The cumulative incidence rate of CA bladder among smokers is A over A plus B, 70 over 7,000, which is 10 per thousand. The cumulative incidence rate of CA bladder among non-smoker is C over CD, 3 over 3,000. It is 1 per thousand. The relative risk is the incidence of disease among exposed divided by incidence rate among the non-exposed, which is equal to 10. The attributable risk, excess risk for the exposed group compared with the non-exposed group, and you usually express as a percentage, and here in this case it is 90%. We can use also software to calculate the relative risk and the other statistical testing attributable risk. We can use it, and this is available in this website. Interpretation of the relative risk. This is also important that in the discussion you have to go for the interpretation. If you find the results, you have to make some sort of interpretation for the interpretation of the results that you have calculated. For example, if the relative risk is equal to 1, this means that the incidence in the exposed is the same as the incidence in the non-exposed. And so there is no evidence association between exposure and the disease. And if the relative risk is greater than 1, then this denotes a larger incidence in the exposed compared to the non-exposed, and thus exposure to the factor seems to increase the probability of developing the disease. And with the same reasoning, if the relative risk is less than 1, denotes a smaller incidence in the exposed as compared to the non-exposed, and thus exposure to the factor seems to decrease the probability of developing the disease. Advantages of cohort study: it indicates clearly the temporal relationship between exposure and the disease, as the cohort members are free from disease at the beginning of disease when we subdivide the group into exposed and non-exposed according to exposure status using different approaches and techniques as we have measured. The investigator can study multiple effects of a single exposure, and as well, we can calculate the incidence rate, and thus we can calculate the relative risk and the attributable risk and the odds ratio. The generated data is of good quality as we are following up the cohort members regularly, and we are obtaining the data accurately, and thus the expected that the generated data will be of good quality, and accuracy and completeness of data is another advantages. Disadvantages of the cohort studies is that we need large sample size as we are going to follow exposed and non-exposed. Usually the sample size is larger. It needs long time to complete the study. It's time consuming compared to the case control study and the cross-sectional studies, and it's inappropriate for rare disease and disease with long latency period. Costly, and need ample resources because we are going to follow up a larger sample size, and as well as for a long period, and we need to carry out investigation to detect the disease as well, and this needs ample resources. Attrition due to loss of some of the cohort members from exposed and non-exposed, this will increase the bias of the study. And also we have difficulty to control the surrounding condition of the study as we are going to follow the participant for very long time. There is a famous example which you can refer to it, which is considered at the first cohort study design, and we can look for the results that they have obtained, which is the Framingham Heart study available at this website address. Thank you very much for this, and we are going to continue in the next videos to discuss further aspects of the cohort study designs.